Welcome back. The front page here I'm going to reserve for my formulas, so I'll come back to the front page a little bit later. Two sampling situations. This refers to the two main things you can do after you take a sample. In both of these cases, we're going to start off by taking a sample of size n. And to be concrete about this, let me give you an example here. Let's say we take a sample of 30 students. Now, what do you do after you have these 30 students? Well, there's two main things you can do. You can either find the mean or you can find the proportion. So in the mean situation, you would then find the mean. Another word for mean is average, right? So find the mean or find the average. And the symbol here is x bar, right? That's the mean that you get from a sample. And in our example here, we take a sample of 30 students, and what I could do is find their average height. And this situation we've been talking about for the past couple of lectures, right? We ask questions like, what's the probability that their average height is less than 6 feet? And then we use the normal distribution to help us answer that. Now the new situation in this section is the proportion situation. So instead of finding the mean, you could also find the proportion. And another word for proportion is percent. The symbol here is going to be p hat. This is the proportion that you get from a sample. And as an example, we take our sample of 30 students, and then instead of finding their average height, what you could also do is find the percent who have a certain characteristic. So the percent who watch Netflix. Now, the proportion situation should sound a little familiar, right? In chapter 6, when we talked about the binomial situation, we asked a similar question, right? In that section, we also took a sample of 30 students. But the difference was, in that section, we asked the question, how many students? How many students watch Netflix? Which is a slightly different question than what percent watch Netflix. So in the binomial situation, when we ask the question, how many students, the possible answers there should just be whole numbers, right? It doesn't make sense to have 5.313 students watching Netflix. So that was a discrete situation. So by changing that question from how many students to what percent, when we talk about percent, you can't have decimals, right? You can't have any decimal there. So by changing the question from how many students to what percent of students, we changed the situation from a discrete situation to a continuous situation. And the reason why I want to change it to a continuous situation is so that I can use the normal distribution to answer questions now. Which brings me to the central limit theorem. So the central limit theorems just tell you when you're allowed to use the normal distribution. In other words, when can I draw this picture that I've been drawing for the last 2 lectures? And when can I use p norm, q norm? In the mean situation, we talked about this already. So in the mean situation, if the sample size is bigger than 30, then no questions asked. For sure, you can use the normal distribution. If your sample size is small, less than or equal to 30, then we need to know that the original population was normal to begin with. in order for us to use the normal distribution. And then moreover, the central limit theorem tells us what we should use for the mean and what we should use for the standard deviation. So for the mean situation, the mean we should use is the original mean of the population. The standard deviation we should use is the original standard deviation of the population divided by the square root of n. And this is what we used in the last lecture. For the new situation of proportions, if n times p is bigger than 10 and n times 1 minus p is bigger than 10, so if both of these requirements are met, then we can use the normal distribution. And what mean should we use and what standard deviation should we use? So in the proportion situation, okay, so I'm using this to distinguish the proportion situation from the mean situation. So in the proportion situation, the mean we should use is the population proportion. So this is the proportion from the entire population. And the standard deviation we should use is big square root p 1 minus p over n. Make sure that entire fraction is inside of that square root. Let's now go through some scenarios and decide whether or not we're allowed to use the normal distribution. Part A. A sample of size 42 will be drawn from a population with mean 52 and standard deviation 9. Now, because we're dealing with both mean situations and proportion situations in this section, we have to first decide whether we're talking about means or whether we're talking about proportions, because the requirements are different in each case. In part A here, it says, notice that I see the words mean and standard deviation. Okay, so that's a good way to decide. If you see the word mean and standard deviation in your problem, then it is going to be a mean situation. Okay, so this is going to be a mean situation, which means we're checking the sample size, whether it's bigger than 30 or whether it's less than or equal to 30. Okay, sample size 42, that's for sure bigger than 30. And if it's bigger than 30, then automatic yes, you can use the normal distribution. So this is an automatic yes. Part B. A sample of size 15 will be drawn from a population with mean 125 and standard deviation 28. Right? Notice I see the words mean and standard deviation there. This is telling me that this is a mean situation again. And then we're just checking whether or not it's bigger than 30. 15 is not bigger than 30. Okay? If it's not bigger than 30, then I need to know, in addition, that the original population is normal to begin with, which means I need to see the words normal population somewhere else in the problem. Do I see that? No. So this is going to be a no. Part C. A sample of size 5 will be drawn from a normal population with mean 60 and standard deviation 12. I see the words mean and standard deviation. This is telling me that this is a mean situation. And then I'm checking whether or not the sample size is bigger than 30. It's not. Okay, if it's not, then I need to see the words normal population somewhere else in the problem for this to be a yes. I do. I do see the words normal population, so this will be a yes, even though we have a small sample size. Part D. The Bureau of Labor Statistics reported that 16% of U.S. workers are government employees. A random sample of 50 workers is drawn. Okay, notice when I read that, I didn't read the words mean or standard deviation anywhere, which means this is a proportion situation. Okay, and because it's a proportion situation, right, we're not checking whether or not the sample size is bigger than 30 anymore, right? When it's a proportion situation, we need to check n times p and n times 1 minus p and check that they're both bigger than 10. Right? It doesn't have anything to do with 30 anymore. The 30 has to do with the mean situation. So for this part D here, because we're in the proportion situation, we're checking n times p bigger than 10 and n times 1 minus p bigger than 10. N is the sample size, in which case here is 50. P is our population proportion, which is going to be that 16%, but as a decimal. So 16% as a decimal is 0.16. Okay, and then let me also fill this part out. 50 is n, 1 minus 0.16. On my calculator, 50 times 0.16 is 8. 50 times 1 minus 0.16 is 42. Both of these have to be bigger than 10 for this to be a yes. 8 is not bigger than 10, right? So this is going to be a no. So you can't use the normal distribution here. Let's pause a bit and let's talk about what these formulas are actually calculating here. So like I said before, the proportion situation is related to the binomial situation that we talked about in chapter 6. So 50 here is the sample size, so we have 50 people total. And 16% is the percent who are government employees. So if you take 50 and times it by the percent, that should give you the number of people out of those 50 that you expect to be government employees. Right? So this is 8 people that we expect to be government employees. What about this 42? If 0.16 is the proportion who are government employees, then 1 minus 0.16 is the proportion who are not government employees. So if you take 50 times that proportion, 42 is the number of people you expect to be not government employees. So what this requirement is saying is that whatever your characteristic that you're interested in, you want to pick a sample size big enough so that you have more than 10 of each, right? More than 10 who are government employees and more than 10 who are not government employees. And that's the criteria. Okay. Part E. The National Center for Educational Statistics reported that 75% of freshmen entering public high schools in the U.S. graduated with their class. A random sample of 35 freshmen is chosen. Okay, so reading that question, I don't think I read the word mean or standard deviation in there. So this would have to be a proportion situation. And because it's a proportion situation, we're checking n times p and n times 1 minus p. N here is the sample size, which is 35. P is our population proportion, which is that percent. That's as a decimal, that's 0.75. Over here, 35 again, 1 minus 0.75. Do it on a calculator and make sure that both of those things are bigger than 10. So 35 times 0.75 is 26.25. And then 35 times 1 minus 0.75 is 8.75. Okay, both of these need to be bigger than 10. This is good. This is not. Okay, so again, this would be a no. Okay, I'm ready to fill out the formulas on the front page now. Let me start down here. This is the workflow that we've been using for the past couple of lectures. There's two main types of questions in this chapter: x to area and area to x. For x to area problems, we go from x to z first, and then from z to area. For the x to z part, we do that using the z-score formula, which is z equals x minus the mean on top divided by the standard deviation. For the z to area part, we do this using R, and the command in R is pnorm, and you feed it to z. To go from area to x, you go in reverse. You go from area to z, and then from z to x. The area to z part we do using the backwards version of pnorm, or the inverse version of pnorm, which is a qnorm, and you feed it the left area of your picture. And then to go from z to x, we do the backwards version of the z-score formula, or the inverse version of the z-score formula, and that is x equals the mean plus z times the standard deviation. And remember, when I say area, I'm referring to probability, percent, or proportion. So all of those things mean area. Probability, percent, proportion. And this is the workflow we use to answer all of the normal distribution questions, which involve these pictures. They could either be shaded to the left, they could be shaded to the right, and they can also be shaded between. And we put the mean in the middle. Okay, and the new thing in this section is the mean that you put in the middle depends. It depends on whether we're talking about a mean situation or a proportion situation. So for the mean situation, the mean you're supposed to use is the original mean of the population. The standard deviation you're supposed to use is the original standard deviation of the population divided by square root of n. And this is what we talked about in the last lecture. And this is for the mean situation. And then the new thing in this section is the proportion situation. So for the proportion situation, the mean you're supposed to use is the population proportion. So this is the population proportion. And the standard deviation you're supposed to use is big square root p 1 minus p over n. Okay, make sure that the entire fraction is inside the square root. And this is for the proportion situation. All right, so let's now try some examples. Example 1. The National Coffee Association reported that 63% of US adults drink coffee daily. A random sample of 250 US adults is selected. Find a probability that more than 67% of the sample adults drink coffee daily. Okay, because we have a mix of mean questions and proportion questions, the first thing you need to do is decide whether we're talking about means or whether we're talking about proportions, because that determines which of these formulas you use for the mean and standard deviation. Notice that when I read this question, I didn't read the words mean or standard deviation anywhere in that question. This would have to be a proportion question. Okay, let's go ahead and use these formulas to write down what mean we're supposed to use and what standard deviation we're supposed to use. So the mean we're supposed to use is P, which is the population proportion. Okay, that's the proportion of the population who have the certain characteristic we're talking about. Here we're talking about drinking coffee. So what proportion of the population drink coffee? 60% of the US adults drink coffee. So population proportion, the mean is going to be 0.63. So written as a decimal, so convert that to a decimal. The standard deviation we're supposed to use is this big square root formula. So big square root p 1 minus p over n. So big square root p, which is 0.63, parentheses 1 minus p, 1 minus 0.63, over n sample size. How many people? 250 people here. So 250. Okay, make sure that this entire fraction is inside that square root. And then on my calculator, I just have to make sure that it looks exactly like that. So if you're using decimals, the easiest way to do it is to click on the square root first, and then click on the fraction button, because that ensures that the fraction is inside the square root, and then go through and fill in the rest. So up top, 0.63, parentheses 1 minus 0.63, close parentheses, on the bottom 250. Okay, round this to 3 decimal places. 0.031. Okay, so for this question, I'm going to use a mean of 0.63, a standard deviation of 0.031. Now let's draw our picture. Okay, put the mean in the middle, which is the 0.63. And then 2 more decisions here. We have to decide whether this is a x to area or whether it's an area to x. And then we have to decide whether the picture is shaded left, shaded right, or shaded between. Okay. Find the probability. Okay, so I want find the area. This is find the area. So I want area as my final answer. This would have to be an x to area question then. So this is a proportion, and it's also an x to area. Okay, let's draw the rest of my picture. Find a probability that more than 67% of sampled adults drink coffee daily. Okay, so what's on my x-axis here are actually proportions, right? Because we said this is a proportion question, so these are all proportions on the bottom here. So this should go on the x-axis. That's 67% as a decimal of 0.67, which should go right here. And is this shaded left, shaded right, or shaded between? More than 67, so that's shaded to the right. Okay, so we have our setup. Shade to right, x to area. X to area, first thing I need to do is the z-score. So we'll do z-score next. Okay, x, which is the 0.67, minus our mean, which is the 0.63, divided by the standard deviation, which is the 0.031. Okay. All right, so on decimals, fraction up top, 0.67, minus 0.63 on the bottom, 0.031. Rounded to 3 decimal places, this is 1.290. Right, now that I have my z, next thing for an x to area question is to go z to area using p-norm. Okay, so p-norm in R, 1.290, 0.901. Okay, is that my answer? It doesn't look like my answer, right? Because that's 90.1%. That looks like a small area, so it should be pretty small. Remember, the way p-norm works is you feed it a z, it spits out the left area. Are we looking for the left area here? No, right? We're looking for the right area. So 0.901 refers to the area on the left, which is the unshaded part. To get the other side, you do 1 minus. So last step here, 1 minus. So 1 minus 0.901, 0.099, which is 9.9%. Right, that matches the picture better. Example 2. The Institute for College Access and Success reported that 68% of college students in recent year graduated with student loan debt. A random sample of 85 graduates is drawn, found a probability that between 65% and 80% of people in a sample were in debt. Okay, first thing, we need to decide whether we're talking about means or proportions. Okay, think back to when you read that question. Did you see the word mean anywhere in the question? No. Okay, so this would have to be a proportion question again. Okay, let's go ahead and write down the mean we're supposed to use and the standard deviation we're supposed to use. Okay, for a proportion question, the mean we're supposed to use is the population proportion. So population proportion, so this is the proportion of the population who we're talking about have debt. 68%. 68% of college students in recent year graduated with student loan debt. So 68% as a decimal. 0.68, and then standard deviation we're supposed to use is the big square root formula. It's going to be p, 0.68, 1 minus p, 1 minus 0.68, over n, sample size, how many people? 85. All right, so standard deviation we're supposed to use here is going to be square root. Click the fraction to force that fraction to be inside that square root. Up top, 0.68, parentheses, 1 minus 0.68, and then 85 on the bottom. Okay, rounded to 3 decimal places, this is 0.051. Okay. Okay, next up, draw our picture. Put the mean in the middle. It's this 0.68. Okay, and then that tells me that the x-axis here are my proportions. And then 2 things to decide. Is this area to x? And then decide whether the picture is shaded left, shaded right, or shaded between. Okay, it says find the probability. Okay, probability is the area. Find the area. Which means I want area as a final answer. So this would have to be x to area. Okay, and then 65%, 80%, right? These are proportions, which means they go on the x-axis here. 65%, that's 0.65. That's over here. 80%, that's 0.80. That's on the right side here. And it's asking between. Okay, so this is shaded between. We're looking for the area between 0.65 and 0.80. Right, and this is an x to area question. First thing for an x to area question is going to be z-score. Okay, I have 2 x's here. Right, these are my x's. Which means I need 2 z-scores. Okay, so my first z-score, I'll do it for the 0.65, so 0.65 minus the mean, which is 0.68, over the standard deviation, 0.051. Okay. The other z-score for the 0.80 minus the mean, 0.68, divided by the standard deviation, which is the 0.051. Okay, so calculator, first one, 0.65 on top, minus 0.68 over 0.051. Okay, that's negative 0.588. The other z-score, that's 0.80 minus 0.68 over 0.051. And that's 2.353. Okay, once again, round these intermediate steps to 3 decimal places. I have my z's. Now I need to go from z to area by doing p norm for both my z's. So p norm negative 0.588, and then p norm 2.353. All right, the first p norm is 0.278. The second p norm is 0.991. Okay, these are both left areas that's spit out by p norm. To get the area in the middle, you subtract. So bigger one minus the smaller one. So 0.991 minus 0.278. And then final answer is going to be 0.713. Example 3. A new medical procedure produces side effects in 35% of patients who receive it. In a clinical trial, 80 people undergo a procedure. What's the probability that 25 or fewer experience side effects? Okay, first thing we need to decide is this a mean situation or a proportion situation? Right. When I read that, I didn't read the words mean or standard deviation anywhere. So this would have to be a proportion situation. And then let's go ahead and write down the mean we're supposed to use and the standard deviation we're supposed to use. So the mean we're supposed to use is the population proportion. Okay, we're talking about people who experience side effects here. So what proportion experience side effects? 35%. Okay, so as a decimal, that's 0.35. Standard deviation, this is the square root formula. So p, 0.35. Parentheses 1 minus p, 1 minus 0.35, over n, sample size. So how many people total? 80. Okay, not 25, the bigger number, 80. Okay, so on my calculator, square root, fraction, make sure the fraction is inside that square root. Up top, 0.35, parentheses 1 minus 0.35, over 80. Okay, round to 3 decimal places. This is 0.053. Picture time. Put the mean in the middle. Our mean here is 0.35. And because this is a proportion situation, my x-axis here are my proportions. And then we have to decide, is this x to area to x, and then decide whether this is shaded to the left or shaded to the right, or shaded between. The question says, what is the probability? All right, probability means area. What is the area? So I want area as the final answer. This would have to be an x to area question because I want to end up with area at the end. And then is this shaded to left, shaded right, or shaded between? It says 25 or fewer. So fewer means less. So this should be shaded to the left. But should I put 25 right here? The answer is no. Okay? You don't put 25 on the x-axis, right? Because our x-axis is proportions. They should be decimals. So 25 is a whole number. So what I need to do first, and this is different from the other 2 examples, is that I have to convert this whole number to a proportion first. Right? Because right now it's a whole number, 25. So convert to a proportion, it means 25 out of the total, which is 80. And so the first thing I need to do is convert that to a proportion. And that's round this to 3 decimal places also, so 0.313. And then put that on your x-axis, because now it's a proportion. So 0.313 is actually on the left side. And we said it was to the left. Okay, notice how here we were given a whole number that we had to convert to a proportion, but the other two examples, we didn't have to convert because we were given the proportion to begin with, right? We were given the 67%, and for example 2, we were given the 65% and the 80%. So those were already proportions, and we can just put them on the x-axis. Okay, so now that we convert that to a proportion, we said this was x to area. X to area, first step would be z-score, and then p-norm. So z-score, x minus the mean, or x is the 0.313, minus the mean, 0.35, divided by the standard deviation, 0.053. Okay, our up top 0.313 minus 0.35 over 0.053. Okay, round this to 3 decimal places. This is negative 0.698. Okay, we're not done. The only thing we did was we did the z-score. That gets us from x to z, from z to area, p-norm. Right, so p-norm negative 0.698, 0.243. Okay, so sometimes this is your answer, sometimes you have to do a 1 minus. P-norm spits out the left area. And the question is, are you looking for a left area? Yes, right? We are looking for a left area, so this is exactly our answer. The 3 examples that we just did, notice that they were all proportions. Proportion, proportion, proportion. And notice that they were all x to area, x to area, x to area, x to area. So for a proportion situation, there's actually not a good way for me to ask it as a area to x question. So that kind of simplifies matters a little bit for you. If you know it's a proportion situation, then for sure it's going to be x to area. All right, so the lab for this section is going to combine the means together with the proportions. And notice I didn't do any mean questions in this lecture, because if you want a refresher on the mean situation, take a look again at the last lecture, 7.3. And what I want to do on this page is go through and just talk through how to decide whether it's mean or proportion, how to decide whether it's x to area or area to x, and how to decide whether the picture is going to be shaded left, shaded right, or shaded between, because I think that's the hardest part. Number 1, the College Board reports that in 2013, the math SAT scores were normally distributed with mean 514 and standard deviation 118. Students scoring in the top 2% were considered for a scholarship. What SAT score was required to be eligible for a scholarship? Okay, so when I read that, I did read the word mean. So this is going to be a mean situation. So this is means. And then let's go ahead and write down what we're supposed to use for the mean and what we're supposed to use for the standard deviation. So for the mean, it's going to be whatever mean is mentioned in the problem. So that's the mean of the original population. So that's 514. Standard deviation is going to be the original standard deviation, which is 118, divided by square root of the sample size. What is the sample size here? Is it 2013? Is it 514, 118, 2%? It's none of those. So if you're not given a sample size, we're going to assume that the sample size is 1, which means when you do this calculation, you're just using the original standard deviation. Okay, let's draw the picture and put the mean in the middle. So our mean here is 514. And then just to help me later on, this 514, I'm going to label what this x-axis represents. This 514 is a SAT score. All right, and then two more decisions we have to make. Is this an x to area or an area to x? And then whether it's shaded left, shaded right, or shaded between. So for means, it could be either one. Right? It could be x to area or it could be area to x. So you do have to decide here. It says what math score, right? What math SAT score? We said SAT scores were on our x-axis, so actually this is asking what x. So it's looking for x as the final answer. So this would have to be an area to x question. Okay, another way that you can figure this out is notice that I'm giving you this 2%, right? So I'm giving you an area. So I'm starting you off with an area, so it would have to be the one that starts off with an area, which is area to x. Okay, the rest of my picture. Is it shaded right, shaded left, or shaded between? Top 2%. Okay, top 2%, highest 2%. That will be actually on the high side, on the right side. So this will be shaded to the right. That 2% we said was an area that goes up here. As a decimal, that's 0.02. And I'm looking for this x. So that's the setup for number one. Area to x, so next thing you would do is area to x, you would Q norm the left area, and then you would find the x. Number two, on a certain television channel, 18% of commercials are local advertisers. A sample of 120 commercials is selected. What is the probability that more than 20% of the commercials in the sample are local advertisers? Okay, when I read that, I don't think I said the word mean anywhere. Right, so the mean is not mentioned here at all. This would be a proportion. Okay, we said proportions were always going to be x to area, so that makes that part easy. And then let's go ahead and write down the mean and write down the standard deviation. Okay, so for proportions, the mean is going to be the population proportion. So this is, we're talking about commercials that are local advertisers. So what percent are local advertisers? Or what proportion? It's this 18%. As a decimal, that's 0.18. Standard deviation is that square root formula, 0.18. 1 minus 0.18. Over sample size. It would have to be this 120. Okay, let's draw a picture. Put the mean in the middle. That's the 0.18. And so for proportion situations, my x-axis are going to be proportions. And then the rest of my picture, I need to put this on my picture. Is that an x or is that an area? So up here, that 2% was an area. Here, is that an area? No, that's an x. And the reason why it's an x is because for proportions, it's always going to be x to area. So whatever I'm giving you has to be x, right? I wouldn't be giving you an area because that's what I'm asking you to find, right? So this 20% is an x, which would go on the x-axis with the other proportion, the 0.18. So that would be 0.20 over here. And then is this shaded left, shaded right, or shaded between? More than 20%, that would be shaded to the right. Okay, this is x to area, so then your next step would be to do z-score and then p-norm. 3. The lifetime of a certain automobile tire is normally distributed with mean 40 and standard deviation 5. Between what two lifetimes do 80% of tire lifetimes fall between? I saw the word mean. This will be mean. Okay, let's write down our mean and standard deviation here. Okay, for the mean situation, the mean is just whatever mean is mentioned in the problem. Standard deviation is standard deviation mentioned in the problem divided by square root of n. Okay, mean here is going to be 40. Standard deviation is going to be the 5 divided by square root of, do I have a sample size here? It's not the 40, it's not the 5, it's not the 80%. Okay, I'm not given a sample size, so we're going to assume this is 1, which means you're just going to use the original standard deviation. Draw my picture. Put the mean in the middle, that's 40. And then to help me, this 40 was what? It was a lifetime, entire lifetime. Or just miles, right? Okay. So 2 more decisions. The picture, shaded, left, right, or between, and then whether this is x to area or area to x. So for means, you do have to decide, right? It could be either one. So if you have a mean situation and I'm giving you a percent, that percent is an area. Right? As opposed to in a proportion situation, if I'm giving you a percent, that's an x. So in a mean situation, if I'm giving you a percent, it's an area. So you're given the area to start. This would have to be area to x. And then the rest of my picture, I want a between, right? I want 2 lifetimes. So those are x's. I want 2 x's that would have 80% between. An area of 0.80 between. Okay, area to x. Your next step would be Q norm and then the x formula. 4. Airlines often sell more tickets for a flight than there are seats because some ticket holders don't show up. An airline estimates that 90% of ticket holders actually show up for the flight. If the airline sells 105 tickets, what's the probability 100 or fewer of the ticket holders will show up for the flight? Okay, so reading that question, I don't think I mentioned the word mean at all. So this would be a proportion situation. Okay, which we know automatically is going to be x to area. So our mean and our standard deviation. For a proportion situation, the mean is going to be just whatever percent is given in the problem. That's 0.90. The standard deviation is that square root formula. So 0.90, 1 minus 0.90 over n, sample size. How many total? 100 or 105? Which one? It's the bigger one. So 105. Okay, let's draw our picture. Put the mean in the middle, which is the 0.90. And then to help myself later on, my x-axis here are my proportions. Okay. 100 or fewer. Okay, so I know this is fewer. This is going to be shaded to the left. 100, is that an x that goes on the x-axis? No, right? Our x-axis is proportions. They should be decimals, like this 0.90. That 100 is a whole number. So that can't be right to put on the x-axis. So this is the same as example 3, right? I'm giving you this 100, and you would want to put it on the x-axis, but right now it's a whole number. So you actually have to convert that to a proportion before you put it on the x-axis. So we have to convert to a proportion. So 100 converted to a proportion would be 100 out of the total, which is 105. So 100 out of 105 is 0.952. Okay, and that's what you put on the x-axis. So it's right here. And we said the shade is here to the left. 5. The lifetime of light bulbs have a mean. So I saw the word mean. I know for sure this is a mean question. 1,500 hours and a standard deviation of 100 hours. A sample of 50 light bulbs is tested. What's the probability that the sample mean lifetime is between 1,490 and 1,550? All right. It's a mean situation. Let's write down the mean and a standard deviation. The mean here is 1,500. Standard deviation is the original standard deviation, which is 100 divided by square root of n. Are we given a sample size here? Yes, we are, right? A sample of 50. So if you're given a sample size, put it there. If you're not given a sample size, put a 1. Okay, so we do have to adjust the standard deviation here. And in the picture, put the mean in the middle. It's the 1500. And label what this x-axis represents. It's lifetime. Or hours. Okay. Now, is this an x to area or an area to x? What is the probability? What is the area? Okay, this would have to be x to area question. Okay, I'm also giving you these two numbers, right? Those are hours. Hours went on my x-axis, so actually these are x's. So another way to think about this is I'm giving you x's to start with. It would have to be x to area. Let's go ahead and put these up down here. So that's 1490 here, 1550, and then it's between. So this is x to area between. And then your next step would be to x to area z-score, both of those x's, and p-norm, both of those x's. All right, have a good day. See you next time.